Good morning, everyone, once again. I hope that everyone can hear me clearly and that you can see me. So I'd like to welcome you to today's session. My name is Gloria Maruti, and I'm going to be your moderator for this session. And in today's session, we'll be diving into the challenges and solutions around energy reliability for commercial and industrial businesses with insights from industry experts. And we really appreciate you for taking the time to join us. And we encourage you to engage with us through the chat and the Q&A section. And we'll be having a session at the very end to address all your questions and concerns. And to kick us off today, before we dive into the session, I'd like to take a moment to acknowledge our partners, the Confederation of Tanzania Industries, and I'd like to hand it over to Engineer Benedict Lima to give us a brief introduction. Welcome. Sorry to cut you short, Engineer. I don't think we are able to hear you. Maybe you can just unmute your mic.
Hello, can you hear me now?
Yes, we can. Thank you.
That's great. That's great. Okay, fine. You are welcome all. Sorry for a little bit of delay because of technical issues. However, now we can proceed. Warmly welcome Ariya to give us the subject of power stabilization. As you know, CTI is supporting the industry vision. The mission of us is to ensure that we provide the services and the product which industry are producing are of good quality so that we can be competitive in the market. With those few remarks, let me go straight to you, Ariya. Come in with your topic, then we'll chip in between for more clarification and questioning. Thank you very much.
Thank you so much, Engineer Benedict, for that introduction. And I guess we can dive into today's session. So I'd like to introduce to you the first, the two speakers for today's session, and that is Mr. Troy Barry and Arshad Akbar. Troy is a registered professional engineer and brings global expertise in energy storage, smart controllers, and distributed generation. And he has a vast experience from across 3 continents. And Mr. Arshad Akbar with him brings years of experience in logistics, supply chain, operations management, and business development. And he also leverages ICT to enhance efficiency in oil and gas and mining. So over to you, Arshad. Welcome.
Thank you, Gloria. Good morning, everyone. Thank you, everyone, to join this session this morning. I'm pleased to introduce you to Ariya Finergy. Founded in 2016 on a powerful vision of sustainable progress, Ariya Finergy embarked on a mission to revolutionize Africa's energy landscape. In a remarkably short time, Ariya has not only established themselves as innovators, but have risen to become leaders in integrated energy solutions across the country. We've established ourselves in Kenya, Tanzania, Uganda, DRC, and continue to expand in other countries within Africa. Ariya Finergy specializes in providing comprehensive integrated energy solutions tailored for Africa. The expertise spans across key areas including solar PV technology, advanced battery storages, sophisticated energy management systems, and critical power stabilization. This integrated approach ensures optimized operations for businesses and communities relying on their solutions. Over 57 systems having been implemented across East and Central Africa, which comprises of over 20 megawatts of solar PV, over 50 megawatt hours of battery energy storage systems, and over 6 MVA of power stabilization. So Ariya Finergy is not just providing energy, We are building a more sustainable and efficient future for Africa. So let's learn more about the impactful work that we do. Now, you might be wondering, what exactly does Ariya Finergy do? Let me walk you through our key services and how they can benefit you directly. Let's start with solar PV. When you think solar, think quality and reliability. Ariya Finergy provides professional design to optimize performance for your specific site. We use only high-quality components because we believe in long-term value. Our expert teams handle installations and commissioning, ensuring everything is set up perfectly. And crucially, we adhere to 100% compliance with international standards, so you know you're getting a top-tier solar solution. Moving on to battery storage. Energy storage is becoming extremely crucial. Ariya Finergy specializes in integrating cutting-edge storage technologies to help you maximize energy efficiency. This translates directly to minimizing your operational costs, something everyone is looking for, and perhaps most importantly, battery storage ensures uninterrupted operations for your businesses, keeping you running smoothly no matter what happens to the grid. Then there's power stabilization. If you're dealing with grid instability, you know the headaches it causes. Our power stabilization solutions provides uninterrupted, seamless power, giving you autonomy from grid instability. Imagine the impact: zero wastage, increased productivity for your teams, and an uninterrupted, seamless power, giving you autonomy from grid instability, ensuring you have a stronger market share because you can deliver consistently even when others can't. And to make this all accessible, financing. We know investment is a consideration. Ariya Finergy offers flexible financing solutions with minimal upfront costs. We have options like power lease agreements, power purchase agreements, and installment sales to fit different budget needs and financial structures. Ariya Finergy services are all about providing practical, effective solutions to real-world energy challenges, especially in Africa. We're here to help you optimize your energy, improve your operations, and achieve your sustainability goals. Let's talk about how we can tailor these services to your specific needs. Let me introduce you to my colleague, Mr. Troy Barry, the CTO of Ariya Finergy, who will take us through the power stabilization journey for industries in Africa. Over to you.
Great. Thanks, everyone, and thank you, Arshad, for the intro. This is really exciting to be here. My name's Troy Barry, CTO and co-founder with Ariya, and been here in Nairobi, based in East Africa for 8 years now. I'm really glad that there are a number of direct flights between Kampala and Dar, because now that we have 3 offices, we have engineers in all 3 countries. I do find myself on that circuit a lot, and I look forward to visiting everyone in Tanzania, either at your facility or at our office in Tanzania as well, as we discuss what is power stabilization. And I think the big revolution in thinking that we want to bring is, typically when you think about solar, I know I did, the conversation is about how can I save off of my energy bill? And that's when you're connected to the national grid, you can save off TANESCO. That's when you're connected to your genset, you can actually reduce your genset by up to 80% on the when solar is connected to that genset. But what can power stabilization do more? And what we want to talk about is how we actually implement it first. So we go in between the grid and your facility. That means that we have total isolation from the grid. Any voltage spike or transient sags are filtered out completely. When there is a grid failure, we do a seamless transition from the grid to battery. And a lot of battery companies say seamless. I think you really need to press them if you're talking to a battery company. Seamless is not 30 milliseconds. Seamless is not 100 milliseconds. Seamless is 0. And if you have very sensitive equipment, extrusion, plastic machines, anything in healthcare, where you cannot have it turn off, you need a 0 millisecond seamless transition. And that's what we provide when we go in between the grid and your operations. That allows us to do this correction of voltage. So not only does it protect your equipment, but actually the equipment is going to run at a higher efficiency. Our stabilization is able to stay connected to the grid between 315 and 470. So if your nominal voltage is 400 or 415, you have a 25% swing on that grid voltage incoming. We stay connected to that and we do a complete correction of that voltage. CTI, really great partners as well. They talked about growing business in Tanzania. I know that the other East African countries are jealous of your low price of power. That really helps business develop. We see cable manufacturers, transformer manufacturers moving to Tanzania. That's good. And likewise, we want to stay connected to that grid cost. So our battery systems in a lot of places, they actually increase the grid consumption, which is a little bit of an interesting mind thought. But why do they do that? They reduce genset operation by so much that they stay connected to the grid. So naturally, your grid connection is going to increase because you're reducing so much of that genset runs. So the battery keeps you connected to the grid. The solar is what decreases your grid consumption. And this last point we hear about the integration of solar PV, so very different from a UPS. Behind our battery, you can put the entire solar system. That allows, when there is a grid outage, the solar PV will lengthen the duration. So there's a slide coming up where we show how we took a 1-hour battery and we ran an entire factory for 10.5 hours because of the solar being connected behind the battery. So again, going on to the next slide, what we want to change here is the thought about solar being something that's only green and only saves you money. It does those things, which is very good. But if we look at it from point of view of how does power stabilization and how improve the power quality and what does power quality mean for your business? So the main discussions that we have with clients across East Africa is around frequent power outages, unstable voltage, and expensive power. You are still paying for it, even in TANESCO's price is quite low, which is very good for business, but you are still paying for it, and solar can reduce that. But specifically on the power quality. So this photo here, this is from a manufacturer in Tanzania. This is preforms that have failed. These are lid closures that have failed. This is all plastic materials that are being taken to waste. They are losing waste material. Not only that, they're having downtime where they're not running their machines. These are 40 to 70,000 bottles per hour. If you calculate revenue at 10 cents per bottle times 40 to 70,000 per hour, you get to see what type of revenue losses are involved with downtime from operation. And there's also the efficiency losses and material losses. There's a difficulty in planning that is involved in machines being off. And what happens if there's a voltage spike that actually causes one of those machines to fail, and then you have downtime on a machine? Nobody likes downtime. The second one, there's a graph there. We'll show that a little bit larger later, but actually shows this is the level of voltage variation that we see. Everybody's familiar with voltage going from plus or minus 25%. You see that voltage variation there. What needs to be pointed out is the 3 lines in the middle. That is the voltage that we give our clients. So we are able to give less than 1 volt voltage variation to the factory. When we do our calculation here about savings and ROI, the power quality, we take everyone through a worksheet that we have, and we can share this with clients. But we only look at your energy savings. We also look at your operation, the efficiency and improvement, machine downtime, cost of machine repair, and waste material reduction. So all of those, we call that revenue stacking. And all of those independent revenue flows have to be associated with batteries. So again, the slide that we're showing here, this is an energy slide, which is a very traditional way of thinking about solar. When the battery comes in, you have to think about operations. And this is allowing your supply chain to purchase raw materials, knowing that your machines are going to operate. This is your sales team being allowed to sign contracts, knowing that your machines are going to operate. I think even if you go to investors or you go to a bank and you say, I want to invest in a new machine, I want to have a third line at our facility, their question is going to be around operational uptime and availability. How are you using that machine? Is it going to pay back? If you have the power stabilization, you're going to be able to say, yes, this machine is going to run. The slide here shows, this is a picture of one of our battery systems on the left. These are lithium iron phosphate batteries, 8,000 cycles. We have now had them in operation for more than 3 years. We are not seeing capacity degradation. They're very high quality batteries along with the rest of our equipment. But going into the batteries and the solar PV now, it is a CapEx versus OpEx question. And the acronym that we use here is LCOE. That is the levelized cost of energy. For solar PV, there's an incredible IRR for solar PV because it is a 40-year project. CapEx has dropped significantly over the last few years. If you have more than a megawatt, we put aggressive pricing here so that everybody can use this as informative. But you will get projects for less than 50 cents per watt CapEx on solar. Your battery storage, if you're doing more than a megawatt hour, will be less than $600 a kilowatt hour. The levelized cost of energy for solar is less than 2 cents per kilowatt hour. This is a very good deal if you're looking at a 40-year lifespan of the project. Similarly for batteries, how we calculate this is you take your battery life cycles, 8,500, divided by the cost, 600, you get an LCOE of 7 cents for that energy. So it does pay back. Again, we're comparing this to the solar, saves you from the national grid, saves you from genset. The battery saves you from genset. Gensets are the opposite. They have a lower capex, but a very high LCOE, as everyone is quite familiar with. So these savings go into our payback time. We generally see that solar is less than 5-year payback. The battery payback can be very quick. We've seen anywhere from 9 months to 4 years, and that is on keeping those machines running and boosting your production. Arshad will get into some case studies on how much production we've boosted, but it is significant in a number of projects. Just a little thing about Ariya that makes us different. We have developed our own vision controller. The controller was needed for 3 reasons. One of them was to integrate batteries. You have to tell the batteries when to charge and when to discharge. The controller we take very high quality products, but they're all off the shelf projects. We assemble them on site. We've integrated them with the controller. The second reason is that we find that we are able to be unique in how we integrate our battery and power stabilization, even the solar system, to other people's facilities. Every facility we go to is different. Some people have multiple gensets. Some clients have multiple transformers. Some people have gensets connected to a sub-distribution board. They want to say, when this genset runs, we want the solar to offset it. When the other genset runs, we have the solar to offset it. To be able to be that creative and capable of the flexibility that's required to integrate with all of our clients, we developed our own controller and we have all those inputs. So if you have a very disjointed facility that you've grown over time, we are still able to integrate the power stabilization effectively into that. The third reason is actually quite interesting as well. Arshad mentioned that we now have 57 systems. When we started, I was able to look at every single system every day. We now unable to have one human or even multiple humans look at every single site. So there's a lot of data points. So we have developed the controller so that we have performance analytics on making sure that the optimal production from our systems is monitored. And again, that ROI, we want that to be as low as possible. That means that any type of downtime needs to be identified quickly. Even little things like when there's too much dust on the solar panels, we can identify that in the data. We can send messages to the client. We can send the cleaning staff. So this is all taken care of with data within the vision controller. That's our proprietary device. It also means that 3 years into the project, somebody can ask for a change, and they can say, we've upgraded our genset. We're putting a new genset here. This is no problem for us. So we can integrate that at any time as we go along. A few more slides here. So on the left, that's another picture of the battery. This was a tea factory in Kenya. They have extremely low voltage. It comes in often at 315 volts, and we're able to stay connected to that and correct it up to 400, which is what they require. This is our engineer on the side who's developing this the vision control portal. So this data portal, these screens are available to the clients. They see these as well. I'm going to dive into that top left graph, which is our client in Kampala. They develop they produce 10,000 liter blow mold tanks. They have extrusion for piping, PVC, HDPE. They do fittings. So they're very sensitive plastic machinery. This day was, you can see 29th of March last year. That's the Friday before Easter. And everyone on Easter wants to go home with a large water tank for their parents or their in-laws. So that's one of their biggest sales days, is the 30th of March. And on this day at 8 in the morning, you can see there was a power outage. There's actually one power outage, a very brief one at about 2 in the morning. That was seamless. But at 8 a.m., the power went off and it stayed off for 10.5 hours. And what the solar and the battery was able to do, keep in mind, this is a 1-hour battery. Reason for that 1 hour is we want to keep CapEx low, but we have solar, and solar is very inexpensive as far as energy. So you might as well put as much as you can on the roof. And that benefit of that shows here. So in the morning, there's the blue line of the battery. It had to discharge to cover the load. The yellow is the solar. It slowly crept up throughout the day. And by about mid-morning, the solar was actually higher than the load, which meant that blue line of the battery went actually negative. So it started charging. So the battery charged up in the middle of the day, which meant they could use it again in the afternoon. A little bit of load shedding late afternoon, but the key thing here is they kept all of their heaters running, kept all of their machines in operation. And as soon as the power came back, which was, it was at 6:30 at night, so 18:30, they went full-scale production again. So there's no waiting for any machines to heat up. They kept their main 10,000 liter tank running. That's the high value addition tank. They kept that running. They were able to produce that throughout the afternoon. And then as soon as the power came back, they went full scale and everything. So there's no delays there. The client was extremely happy at this point because that's their biggest sales day. We kept them running. We kept those machines going. The other two graphs, these are again performance analytics. This is how we ensure that our systems are performing optimally. The data is displayed for us and the client. There are also alarms and notifications and scripts running in the background that notice this without the need of a human coming to work and checking every day. And now a few more things that we have is, now that we have an energy meter connected to, this is our amazing team, by the way. So we're 30 strong. A lot are in Kenya. We are expanding in Uganda and Tanzania. We have an office, Arshad and an engineer in the net house in Dar. And back to the data points here on the side. So once we have an energy meter connected to your factory, we then get data. And what can we do with that data? We can do an energy efficiency review. We display it. We put it on the internet. We put it on the phone. The TV screen is a really interesting one. There's a story. Our first project at the tea factory, they're in a remote village. They were carrying on with business. All of their machines were running. They didn't realize there was a power outage until the local community came up and said, okay, our town is completely dark. We don't hear your diesel generator. What's happening? They thought something was wrong with their line because whenever the power is out, the tea factory has to turn the generator on. this night was dead silence. And so everyone was confused what's happening. And this was one of the first nights that they had the battery. So even the factory staff didn't realize that the power was out. So it took everyone a little bit of time to realize that seamless transition to the battery, nobody noticed. So we've actually had to put TV screens and put these up around people's factories so that they can tell that the power's out. They can tell what the state of charge is of the battery. They can make decisions about when to turn off machines. If it's a very long power outage, they will keep the highest value machines running, and turn off the ones that are lower value. The middle gray area, the optimized energy use, again, I mentioned with that controller, we're able to work with clients that have multiple transformers. The word solar sharing here is a really unique concept that we've implemented at a number of sites where you never know with a factory, you might get an order for machine A on Monday and you might get an order for machine B on Tuesday. And you want to make sure that that asset that you bought, the solar PV, can power either machines. Those machines might be on different transformers. So where do you connect your PV? You can connect it with Ariya, you can connect it to either transformer, and we can share from one transformer to the other and keep that ROI low because that solar is guaranteed to be used by machines in the factory. We've developed time of use. This is really utilized in Uganda where they have cheaper power in the middle of the night. And the load management, I had referred to that as well with the TV screens, but we actually have developed controllable breakers where a PLC can control breakers, turn them on and off based on the state of charge of the battery. So if you want to go full automated control to ensure that your highest value motor stays running, you can have an automated program that turns off the lower value ones and the ones that are unaffected by the power cuts. You keep that highest value machine running. So for an extrusion plant, this might be the tape line that makes the plastic sheets that's used by other facilities. This may be for the tank manufacturer in Uganda. This was their 10,000 liter tank. That's the one with the highest value. It's the one that has the most material loss if it shuts down. At the bottom, seamless power. This is 24/7 voltage and frequency correction. So it doesn't depend on the solar. It's all the time. Seamless. The outages are seamless. That's 0 millisecond transfer from grid to battery. We also have a team of experts. We can do additional reviews on your energy efficiency, on your harmonics. All of this maximizes your savings against grid genset and also those critical points, which is the revenue boosts. I believe the next slide is a video, which is going to go over, thanks Gloria for hitting play. This is going to go over all the points if I miss them, but how power stabilization can improve your business.
Imagine a busy factory. Everything is going smoothly until power goes out. Employees sit idle and engage in banter. As the factory goes dark, profits start to slip away. Every minute of downtime means losses. But what if the machines never had to stop? That's where Ariya's power stabilization solution comes in. By integrating solar PV and batteries, our solution ensures continuous operation even during outages. We focus on your power problems while you focus on growing your business. With Ariya, your factory runs smoothly, saving time and money. Don't let power cuts hold you back. Talk to us today.
Thank you, Gloria. Thank you, Troy, for the informative session about the power stabilization solutions that we've implemented. I would like to touch a little bit more on the case study, but before I do that, there is some frequency and voltage corrections that I'll let Troy talk about.
Perfect. So this, yeah, we have one more slide here. I really want to drive these points home. So the video talked about machine downtime. That can happen two ways. One of that can be from a voltage spike that'll actually cause the machine to fail. That's like a disaster scenario for a business owner. The spare parts might be on the shelf. You spent money to put them up on the shelf and keep them there. they might have to be ordered in, and that's going to create downtime. That's going to keep the OEE of your machine, the availability is going to be low. So these are two graphs. The one on the left is frequency. So the brown line that's squiggling up and down, that is the incoming grid frequency. Frequency determines the speed of your motor. So you have a continuous process where multiple machines need to be in sync. The frequency is going to slow and speed up those machines, and that is going to affect quality of eventual output. The frequency that we give our clients with power stabilization is the blue line in the middle. This ensures that all of the processes run at the same speed, the motors run at the same speed. This is good for quality. The one on the right, this is voltage. So again, for three-phase AC voltage, the pink and two brown lines, that is the incoming grid's voltage. We see this go from 315 up to 470 within the course of the day. The three lines in the middle that are all around right at 400 volts, you see them 399.9, 400.4. This is the voltage that we give our client, and that is whether the solar is high, whether the load is high, whether the genset, whether there's a grid on, we're able to bring that voltage straight to the client. Even if there's a power outage, that doesn't budge. If you have an oscilloscope, you can't tell if the power has gone out or off because we've put ourselves in between the grid and the frequency, between the grid and your facility. Now, as Arshad was introducing, we want to get to the case studies. Where has this actually been done? It sounds really good, but Arshad will take over proof of concept.
Thank you, Troy.
Just before Arshad, before you continue, I'd like to encourage the members to keep on sending your questions in the meeting chat so that we'll have a Q&A session at the very end to address any concerns that you have. Over to you, Arshad.
Thank you, Gloria. Thank you, Troy. I want to share a story about real transformation. So we've implemented a system at PPTL in Tanga where we're striving for peak performance, but they were held back by unreliable power. Machine failures, costly downtime, and lost production were everyday challenges. That's where Ariya Finergy stepped in. We didn't just offer a product, we delivered a solution. At the PPTL site, we implemented an AC-link power stabilization system specifically designed for their needs. We built a robust 1.25 megawatts of solar plant, added a powerful 2 megawatt hours of battery storage systems, all to protect their vital 2 megawatt load, especially those sensitive tape lines that are the heart of their production. But it's not just about hardware, it's about intelligence. Our smart integration and load management systems are like the brains of the operation. Imagine a system that intelligently prioritizes power during any grid hiccups, ensuring critical equipment keeps running smoothly. The impact? It's not just incremental, it's transformative. Reduced machine breakdowns means less stress and low maintenance bills. Increased efficiency means a smoother, more productive operation. And the bottom line, a phenomenal 40% surge in production for PPTL after partnering with Ariya. So this isn't just about numbers, it's about real-world impact. It's about Ariya Finergy empowering businesses to thrive, even in challenging environments. So it's about unlocking potential and driving real progress. The next case study I'd like to talk about is another system we implemented in Uganda, Kampala, which Troy mentioned in his previous slides. So now let's turn our attention to this impactful project. This time showcasing Ariya Finergy's DC-link power stabilization system at Gentex Enterprises in Kampala, Uganda. So Gentex is a leading manufacturer of essential products like UPVC, HDPE, and PPR water pipes and fittings. Reliable power is paramount for their manufacturing processes. Ariya Finergy designed and implemented a robust system comprising of a substantial 2.6 megawatts of solar plant, integrating it with a 2.637 megawatt hours of DC bus, and protecting 2.5 MVA of Gentex's critical loads. The DC-link power stabilization project is specifically engineered to provide seamless power to Gentex's key production lines, their rotomold, injection molding product lines, and many other product lines while susceptible to power surges. So these are energy intensive and highly sensitive manufacturing processes that demand consistent and stable power. The implementation of the DC-link power stabilization has yielded significant operational improvements for Gentex. They have experienced a tangible reduction in machine failures and associated maintenance expenses, and importantly, a notable increase in the overall production efficiency. The quantifiable impact speaks for itself. Gentex Enterprises achieved a remarkable 30% increase in their factory's overall production within just a few months of the system's installation. This case study exemplifies the effectiveness of the DC-link power stabilization system in providing reliable, stable power for demanding industrial applications, leading directly to enhanced productivity and business growth for our clients. Now I'll speak to you about some of the advantages of power stabilization. So this slide illustrates what truly matters to your business and how Ariya Finergy delivers on those priorities. So let's break it down. Imagine 100% business continuity, no more power-related production halts, no more missed deadlines. With Ariya Finergy, you can meet production deadlines consistently, building unwavering customer trust and opening doors to new business growth. Think about extended equipment lifespan. Power surges and drops are like invisible wear and tear on your valuable equipment. Reliable power acts as a protector. So our solution extends your equipment lifespan, saving you from premature replacements and keeping your machinery running longer and stronger. Consider the impact of energy efficiency savings as well. Wasted energy is wasted money. Stable power allows your machinery to operate optimally, eliminating energy waste. This means significant energy efficiency savings and lower electricity bills, directly boosting your bottom line and your sustainability efforts. And finally, optimized OEE. Downtime is the enemy of productivity. By delivering seamless, stable power, Ariya Finergy helps improve your factory's OEE. This means minimized downtime, machines running at peak performance, and consistently high product quality, the cornerstones of a successful operation. Ariya Finergy is dedicated to empowering your business with reliable energy, driving continuity, efficiency, and long-term success. I would like to showcase some of the testimonials we have from our clients for all the implemented projects we have undertaken within the region. And for all the projects that we've implemented, we continue to provide support to these clients with our O&M packages. So we're not only there at the beginning of the journey, but throughout the lifespan of the system. These are just some of the clients that have provided us with their testimonials, and we have many more that we can share. Now let's talk about making Ariya Finergy solutions accessible to you. We understand that financing is a key consideration, and we offer a flexible option to suit different needs and financial strategies, of course. Let's look at our three primary financing models. Firstly, direct sale. This is straightforward ownership. With a direct sale, you own the system from day one. This unlocks immediate benefits. You can benefit also from the capital allowances and tax incentives, reducing your initial financial burden. And crucially, you maximize long-term savings on your energy costs as you own the asset and reap all of the rewards of reduced energy bills for years to come. Direct sale is ideal for those who want immediate ownership and the maximum long-term financial benefit. At the same time, with direct sale, you can pay at different milestones based on the longevity of the implementation of the system. Next is the power lease agreement. The power lease agreement, or PLA, is about flexibility and cash flow management. With the PLA, you spread the costs over time to match your cash flow. This is a significant advantage for budget planning. You can optimize your energy investment without a large upfront outlay, keeping your capital free for your core operations. A PLA is a smart choice for businesses that prioritize cash flow management and want to spread their investment. Finally, the power purchase agreement, or often known as the PPA. So PPA offers the lowest barrier to entry, With the PPA, you pay for the energy, not the asset itself. So this means no upfront capital investment whatsoever. You simply start enjoying immediate savings on your energy bills from day one. So Ariya Finergy's flexible financing options, which we've shared over here on this slide, direct sell, PLA, and PPA, ensure that sustainable and reliable energy solutions are within reach for all businesses of all sizes and financial preferences. We are here to help you to find the right financing model that best aligns with your specific needs and goals. Thank you for listening. Over to you, Gloria.
Thank you so much, Arshad, for the valuable insights. And thank you to our audience. I trust that by now you are able to understand a bit more about power stabilization and how it can impact your business. And just before we dive into the Q&A session, I'd like to encourage you to keep the questions coming in the chat. But just before we get there, we're going to send out a short poll. Feel free to answer the question. I'll just give you a minute or so to do so. Ariya Finergy prides itself in being our client's power partner, and we highly encourage you to be as honest as possible as you answer this question, because we are here to help your business grow. And feel free to answer. Keep the responses coming.
You can see the results of the poll on the meeting chat.
Yes.
What was your vote, Arshad?
Unreliable energy supply.
Yeah. You see that a lot.
I've seen that quite often in Uganda, Tanzania, and DRC. And of course, Zambia as well.
And reliable energy supply seems to be quite popular, right? So we are targeting the right audience, and we look forward to engaging with you further on this. So quick recap on the results. So the question was, which of these is your biggest energy-related challenge? And we had 5 different options, and the one with the highest score is unreliable energy supply. So that is why power stabilization is here. It's the answer to all your problems. And at this point in time, I'd like to open the Q&A session. Feel free to unmute yourself and ask your questions. We are here to give you responses. You can also type in the chat.
I'll ask just a quick question for Arshad. So one of them is how to get a hold of Arshad, and the second one is what's the process when of trying to determine what type of project, what size of project is optimal.
Thank you, Troy. It's a good question. So offices in Tanzania are based in Dar es Salaam as well as in Tanga. Office in Dar es Salaam is in Masaki at Minute House on the first floor. So how do you get hold of us? There's a phone number that was indicated in the presentation. We'll also send it out across to all the participants. But at the same time, CTI does have our contact details. So feel free to reach out. We'll also drop in on the chat the contact details if anyone wants to reach out and get more details about power stabilization. To answer your second question, we have a team of engineers that are based in Tanzania that we all work closely with the client to establish what their current power needs are or power solutions that they require. We have specific data loggers that can measure the number of flickers, the number of power outages, the duration of those power outages, the voltage, the frequencies from the grid, and provide you with a system that's better suited for the needs of that factory or industry. And that ensures at the same time it is as economical as possible to meet with the financial budgets that those industries have. So this is how we've set up our team to be able to provide solutions, the right solutions for the right problem. Thank you.
Great. Thank you so much, Arshad. I can see Dr. Lugano, who is with us, has raised his hand. Feel free to unmute yourself and let's hear from you.
Hello, everyone. Congratulations for the nice presentation. It really enriches the industry on power management, but also on how to be sustainable in uninterrupted power. The issue is before you implement any of these solutions, there should be done a very comprehensive study that can come up with a way forward and actual cost and so forth. So what is the arrangement for this? How is it done and what is the arrangement? Thank you very much.
Maybe Troy, you want to take that up?
Sure. Yeah. So I think the main thing that we want to understand is your peak power demand. We do like to see SLD of the site layout, to see a transformer, see how your gensets are connected. That single line diagram, sorry, SLD single line diagram, we see how the electrical layout is. Really, the solar, the battery, they have different approaches. For solar, we want to get an understanding of how much energy we're going to produce. To do that, we need to do some data logging in your facility. The utility bills really help as far as determining the peak power and the total energy. You may have some loads. Some people run night shifts. Some people do 24 hours. Some is only daytime. So we do need to understand how much of that power is used during the day for the solar to be optimized. We have a model, software model. So we collect the data with a data logger. We compare it to 365 days of sunshine. So we have data there's websites that have data from NASA, which looks at the last 25 years of sunshine and radiation on every little 10-meter square on Earth. So we can, whether you're in Mwanza, Arusha, Moshi, and Mbeya, we can get the irradiation for your specific facility at your location. We overlay those two. So you get a size of, and the software runs for every single different solar size. So whether it's 100 kilowatt, 1 megawatt, 1.1 megawatt, 1.2 megawatt, you will get a payback estimate. And from that model, we can generate an optimal solar PV sizing. Then we take a look at the roof, ground mount area, wherever you have for that power. So you have to first be able to use the power. You have to then second have to have a place to put it. So that's the solar sizing. For the battery, it's more about peak load. We do a little bit of a study about how frequent and what is the duration of your power cuts. One of the reasons we're able to install a very low CapEx system, We find in a lot of places, at least 3/4 of the power cuts are less than 1 hour. And if they go longer than an hour, they might go 6, 7, or 8 hours. So there still is a need to keep a genset. If you're going to have a power outage that's for 8 hours, we don't want to bring an 8-hour battery because that's going to slow down the ROI. But for batteries that are up to 1.5 hours, those cover the majority of the power outages, which means you're going to get maximum benefit from lower capex. So part of this is a little bit is done over phone and email. Tanzania is a very big country. It's not too easy to get everywhere, but we do have a regular circuit. When people show interest, we do a factory visit. We come and meet you in person. I know people want to see that you're real. We're willing to come to your facility and meet and discuss. There's a lot of technical questions that get done a lot easier on a discussion. So Arshad, his team, myself, were able to visit. I'll jump into the question. So the life cycle of the batteries. So we showed earlier 8,500 cycles. Typically per year, for instance, the tea factory, which is in remote Kenya, they utilize their batteries at about 250 cycles per year. So it's not a full cycle per day. I would consider that pretty heavy use. Most of our systems are a little bit less than 1 cycle per day. So if you look at 8,500 cycles, that is more than 8,000 days. That's looking at more than 16 years for this cycle count to be reached. Good question, Ahmed. Thank you. And if there's any more, Gloria, if anyone has their hands up, or please also enter questions in the chat.
Thank you, Troy. At the moment, I can't see any more hands. Let me just check in the chat. I can see that Roy Otieno has asked a question. Have you ever considered being involved in an EV solar-powered charging station? Thank you, Roy, for your question. Troy, you want to address that, or Asha?
I'll let Troy take that.
Yes, I think that's really interesting. We have spoken to some electric vehicle companies. The whole thing is, what we want to show here today is that solar makes sense economically. To get an economic use out of your solar system, the solar system has to have a very high usage rate. So we like connecting to a central solar system to a large facility where they have a portfolio of loads, and it doesn't matter which machine is on. There's always enough machines for that solar to be utilized. The question around the charging of the vehicles is are you constantly charging vehicles in that your solar system is going to be constantly used? Again, kudos to Tanzania. They have a very low electricity price. So I don't know why there's so many electric vehicle companies in Kenya. They should all be in Tanzania, because the benefit of having an electric vehicle in Tanzania at a very low grid price is very huge. And I argue that yes, solar is going to help it, but you don't need it because the grid price is quite low. But you may have a power outage, and then you might have some batteries and some cars that can't be charged up. But again, unless you're having a constant supply of charging, maybe you're an electric bus company and you have 65 buses and there's always at least one bus, then solar would really work for that. We haven't specifically done that yet. We are talking to a few companies. We're open to it. I think there's some neat ways about connecting DC straight to the charger. But generally, the best payback is someone that has many loads and a wide portfolio of loads, where you're not dependent on any single one item to be on for that payback to occur. Thank you.
Thank you. I hope that answers your question, Roy. I think we have time for one more question. I can see there is Amit Party who's asked in the chat. does the performance of batteries deteriorate as cycle count increases?
I mean, the overall thing is over a 15-year life. Yes, the resistance of a battery does go up. What that means is the ability of it to respond with high power does go down. We've seen very good performance from our batteries. So the longest one has been running for 3 years. We have systems that are now crossing the 1,000 cycle point. All of this data is available globally and from the manufacturer. It's another thing to see it on your own projects. So we've been really happy with the batteries that we've installed. Some of them have been remote areas, some of them have been in places down at the coast where it's very hot. We've seen them perform well in these environments. We are not seeing a capacity degradation within up to that 1,000 cycles. So they're still above the nameplate. Typically when batteries are delivered, they're above the nameplate capacity. We're still seeing our systems are above nameplate. So we haven't seen any capacity degradation. Power degradation does occur, but this is part of our sizing. We always do about 20% extra sizing on the power. Payback is really quick. It is possible to add racks. So what we say is, if you do have throughout your 15-year life of your battery, if you do have some degradation that you experience throughout that lifetime, you don't have to replace the whole batteries. You just need to add another rack, and that rack can come in, you can operate with the other ones, and you can increase the power capacity and also the power duration, the energy capacity in the same way.
Great. One final question before we bring back CTI. Do days of autonomy be taken into consideration during industrial and commercial designs? That's from Robbie. Troy?
Sorry, Chloe, I was responding to the question and I can't multitask. Can you repeat?
The question was, are days of autonomy taken into consideration during industrial and commercial designs?
So, I mean, the days of autonomy confuses me a little bit, but we like to go in to start with a 1-hour battery. As I said earlier, we've at least 3/4 of the power outages that we see in the region on average is less than 1 hour. And that's the bulk of the savings, right? It's all about ROI. We don't want to put in a battery that's going to take a long time to pay back. Once it's paid off, you can increase it. You can start going 2, 3, 4 hours. We do put in 12-hour batteries if it's a completely off-grid system. So we've done that for camps. But if there is a grid, generally the grid comes back after an outage, and we don't need to put more than 1 hour. Although once the system is paid off, a client can do an upgrade. For days of autonomy, I mean, if you're going for longer, a genset is always on site when we get there because everybody already has the genset. What we do is we integrate that genset. So if the outage goes longer than 1 hour, and keep in mind, if the solar PV, if it's daytime, that 1 hour battery can be extended. We saw the one example in Kampala where we went up to 10.5 hours. So we can extend the 1 hour with the solar. If it still discharges or if there's a long 4-hour outage at night, we integrate to the genset. We turn the genset on. And that covers, this is an 80-20 rule. We want to cover 80% of the outages with the 1 hour battery. For the 20% that go longer, it's very difficult to have a long-term 8-hour battery and pay it off. So we go back to where the client was before, which is with the genset, we turn it on. As soon as the power is off, we turn it off, we go back to the grid. All of that is seamless. The key thing is too, even if you have a seamless transition to your genset, you're still saving that material waste. You're still preventing the voltage spike that comes through the machine when there's a transition or an outage. So yes, we're saving the genset fuel up to 1 hour. We're also keeping the machines running so that whole transition period, you don't lose. Let's say a client makes a pipe. Pipe might be in sections, and you don't want to especially the extrusion pipes, it might be 600 meters roll. You don't want to get to meter 592 and have a power outage and have to sell some partial roll. So we keep that machine running. And yes, if the outage is longer than an hour and it happens to be at night, we do the seamless transition to genset.
Awesome. Thank you so much, Troy. I trust that answers your question, Robbie. And at this point in time, we'd like to call it a day. But just before we do that, I'd like to bring back Mr. Engineer Benedict from Confederation of Tanzania Industries. And the conversation doesn't stop here. If you look at the chat, you can see that we have put in our email addresses for any further inquiries, questions. Feel free to reach out. Anytime, any day, our contact information is displayed on your screens. Feel free to call us out. So thank you. And over to you, Engineer Benedict.
Thank you very much, Gloria, together with the Ariya team, inclusive of all the participants, for listening carefully and also asking some questions. And the questions were well responded. We have your addresses. And hopefully you'll share the presentation with the CTI later. I'm just thanking you again for a well informative presentation, well documented, and the screen was clear. We were following that very well. Thank you very much indeed, Gloria and the Ariya team. Asante sana.
Thank you. Unless there's any more remarks from the audience, we'd like to call it a day. Please stay in touch, reach out to us. We are here to address all your power problems. Our core focus is to focus on your power problems as you focus on your core business. Without further ado, thank you so much and enjoy the rest of your afternoon.
Thank you, everyone.
Okay,
Have a
thank
good
you.
day.
Asante sana.
And thank you, CTI, for partnering with us. Asante sana.
Thank you very much.
Asante sana.
Yeah,
We
thank
will
you,
send you the
CTI.
presentation
Thanks. All right.
soon.
Thanks.
And
Okay, yeah,
hopefully you
appreciate
can
the
then forward it
presentation,
to all the participants and members of CTI within Tanzania and East
All right,
Africa.
thanks.
Thank you. Bye-bye.
Thank you.
Thank you
All right,
so
bye.
much.
Bye.